Good morning and welcome to this Energy Vaasa Talks webinar. I am Juha Ripatti, Head of Business Intelligence at Westenergy, and I'm delighted that you joined us today to hear about circular waste to energy. Today we will be discussing how our sector can help all of society to refine, integrate and decarbonize better and move towards a more sustainable future. First, I'd like to introduce our studio host, Sanna Hautamaa, the real powerhouse whose efforts have made this webinar possible. So thank you, Sanna.
Thank you.
Sanna might not be very visible today, but she will be forwarding all of your comments and questions to us here, so please don't hesitate to join the discussion. Today we will hear two keynote speeches on what's happening in the waste to energy sector in Europe and Finland. After that, we'll take a look at what kind of carbon handprint cutting-edge Finnish technology can have globally. And finally, we'll explore what Westenergy and our partners have already done and are going to do to increase energy and material efficiency and decrease emissions. Joining us online, we have Technical and Scientific Officer Fabio Poretti of CEWEP, Confederation of European Waste-to-Energy Plants. Good morning, Fabio.
Good morning, everyone.
Good morning. How are you?
Good, pretty good, very good, and warm welcome from Brussels.
Great to hear you. Welcome. And furthermore, we have Senior Advisor Karoliina Muukkonen from Finnish Energy. So good morning, Karo, as well.
Good morning.
And so delighted that you could join us.
Yes.
In the studio, we have Suvi Karoliina of WEBIC and Henri Kinnunen of Voima Corporation. So, Suvi, would you like to introduce yourself?
So, good morning to everybody there behind the screens. My name is Suvi Karoliina and I'm the director of WEBIC, which comes from the words Vaasa Energy Business Innovation Center. And our main target is to enhance this multidisciplinary research done in the fields of energy transition and sustainable development.
Awesome. Great to have you here.
Thank you.
And Henri?
Good morning. So my name is Henri Kinnunen. I'm the CEO of Voima Corporation. And Voima is a company that wants to make a big change and an impact in the world. So we are big believers in the circular economy and especially waste-to-value solutions. So I think we will have a fascinating webinar ahead of us. So we will touch all these topics. So nice to be here.
Thank you so much. All right, let's move forward now to our first presentation. There are over 500 waste-to-energy plants in Europe refining waste into value for all of society in terms of recovered energy and materials. We work to connect the waste management system and the energy system with all of society. We've been practicing sector coupling long before it became a buzzword. So the first waste-to-energy plants were built in Europe over 100 years ago. But of course the modern facilities are the result of a long process of refining and improvement. As an important component of two key European value chains, this sector is also very much governed by European regulation. And there's a lot of happening in the EU right now. So to know more about what's happening and how it's going to affect us and what the future is going to look like, we have Fabio Poretti to tell us. So please, the screen is yours, Fabio.
Good morning, everyone. I'm Fabio Poretti. I'm the Technical and Scientific Officer at CEWEP. And today I'll give you a very short overview of the waste-to-energy role inside the European Green Deal. Well, first of all, CEWEP is the Confederation of European Waste-to-Energy Plants, meaning waste incineration with energy recovery. There are about 500 plants in Europe, treating around 100 million tons of residual non-recyclable waste. CEWEP is based in Brussels, where we directly closely work with the EU institution and especially the European Commission. And it's actually a very interesting period for being in Brussels, because as you might know, Europe has started a new green revolution called the European Green Deal, which is meant to transform the EU economy into a sustainable future. So This is the master plan of the European Green Deal a little bit more in details, where you can see that it covers different aspects and different policies, starting first of all from the decarbonization and the climate neutrality objective to 2050, going down to circular economy, zero pollution, and so on. And as I said, one of the main target in the political agenda of the European Commission is the climate law. And recently, a provisional agreement has been reached for stepping up Europe's climate ambition from 40% to 55% greenhouse gas emission reduction target by 2030 compared to the levels of 90s. And there will be different key instruments to achieve these goals. But among the main policy tools, we will have the revision of the Renewable Energy Directive, as well as the revision and the reinforcement of the ETS, which is the European emission trading system, and the current market price, carbon market in Europe that will try to directly address this goal. And then also the revision of the Energy Efficiency Directive. This is a list of different policies that directly touch waste to energy and that we are actively following. And there will be, let's say, the legislative proposal is expected from the Commission on this energy and climate package by middle July this summer. And so what is the role and the roadmap of waste to energy inside the European Green Deal? Well, this is based on two main pillars. The first one is making the circular economy happening, because material and energy recovery from waste are strictly linked with each other, and they are complementary in order to reach sustainability and in order to reduce landfill disposal. And the second big pillar in this plan is the contribution to climate protection in a decarbonization perspective, because waste to energy helps the diversion of waste from landfills and replace fossil fuel for the equivalent production of electricity and heat. But we will touch this in a second. Before, let me spend a few words on the new circular economy package targets. As you might know, the main objectives will be the one on landfill, so the maximum landfill disposal of 10% in 2035, and a minimum recycling target of 65% in 2035, with some derogation for some member states. So the question that we should ask ourselves is, what would happen in the future if all these very ambitious targets will be reached by all member states? Well, we try to develop also at CEWEP a circular economy calculation tool that you can also find online on our website, and you can actually also play with the different assumptions to generate different scenarios. But considering some very conservative assumption, this could be a possible picture that we could see in 2035. I cannot enter into the details of the numbers for time constraints, but basically you can see on the left the amount of municipal waste, and on the right side the amount of commercial and industrial waste. So considering accordingly the amount of flows that goes to separate collection and the relative amounts of residues which are generated from sorting and recycling activities, well, you can see in the middle the amount of residual non-recyclable waste that we will still have in 2035, potentially around 142 million tons of waste. Well, considering the actual waste to energy capacity around 90 million tons, and also considering a little bit of co-incineration capacity, we would still have a gap to fill in order to treat this residual waste of around 40 million tons. And so, as you can see, although all member states will be able to reach these ambitious targets, we will still have residual waste to treat, and that will not disappear, and that we will have to tackle. And what actually happens where and when there is not enough residual waste treatment capacity? Well, unfortunately, in this slide, you can see some articles from European press about illegal waste traffic and the crime of illegal waste import and export, which is happening pretty much all over the European borders, without also talking about unfortunately the open fires in warehouses that sometimes took place with very bad environmental and health issues. And all of this obviously should be avoided, as landfilling should be avoided, because in a material and energy recovery perspective, landfill do not give any additional value, but also in a climate perspective, landfills are big emitters of methane, which is a greenhouse gas 25 times more potent than CO2. And here comes the second big contribution of waste to energy in reducing greenhouse gas emission. Because nowadays, Europe still landfills around 175 million tons of non-mineral waste, emitting more than 140 million tons of CO2 equivalent. Well, if we would be able to divert this 175 million tons to higher steps in the waste hierarchy, such as to waste to energy facility, we would be able to save 153 million tons of CO2 equivalent. So waste to energy through landfill diversion, fossil fuel replacement, and material recovery from bottom ash already has very positive climate impacts. And this could bring even further contribution, bringing to negative CO2 emissions wherever carbon capture use and storage technologies, known as CCUS technologies, can be applied to the waste to energy sector. There are already different projects going on in Europe in different waste to energy plants, and I'll leave here for references some development of the CO2 transport network that has to be developed, and these will be key in the future. So other than CO2 reduction, also CO2 removals and CCUS technologies have been acknowledged by the European Commission, and an important tool that will be used to fund these type of projects will be the Innovation Fund. And I'll be happy to give you more insight maybe during the discussion. I leave you with a final outlook on the future synergies that the waste to energy sector can have, and especially with the hydrogen production. This is something that the sector has started to explore, and there are different ongoing projects in Europe. One of them is in Germany at the Wuppertal waste to energy plant, where an electrolyzer has been installed, and with the electricity produced from the waste to energy process, hydrogen is produced and then used in 10 fuel cell power city buses for cleaner urban mobility. So in conclusion, to wrap up, what's the role of waste to energy? Well, waste to energy will continue to play in the next years, and within the European Green Deal, a key and a fundamental role. First of all, for the true creation of an integrated waste management system, but also for the development of sector couplings and new synergies with the other technologies and processes. And finally, the full integration into clean local energy infrastructure. And for this, continuous dialogue with their communities has to be brought out to discuss the environmental, but also social and economic impacts that waste to energy can bring. So this, I conclude my presentation. I apologize if I've been a little bit fast on some slides, but I'll be happy to answer your question during the discussion. And I really thank you for your attention.
Thank you so much for this in-depth introduction on what's happening in Europe in terms of the waste-to-energy sector and the regulation and policies and future developments. I can certainly see a lot that's going to affect us and a lot that we are already working with. And I think our sector is quite open in how it does its business and how we try to make regulation into actual practice. So we're open to this kind of change. But of course, there are some voices that are saying that combustion processes and so on shouldn't be a part of the future solution. And then on the other hand, we can see that a large part of Europe still landfills most of its waste, which creates a lot of pollution. So there is this dichotomy, so to say. And I think we need to try and tackle this elephant in the room a bit. What kind of solutions do we have to address these concerns? And you talked about these new technologies that are coming. How can we move forward with them?
Hi, Joa. Thank you for the question. It's definitely a very important topic, as I also try to touch in my presentation. First of all, I have to say we don't have to forget what's the real and primary purpose of waste-to-energy plants. Because before being energy production facilities, we have to remember our roots, that we are waste treatment facilities. And that's key to remember when we talk about combustion and when we talk about thermal treatment of waste and why we do that. And so in Finland, the situation is quite well about landfilling, but in Europe, you have to remember that still 60 million tons of municipal waste are still landfills, without even talking about commercial and industrial waste. For that will be even more. And I also left some figures in my presentation. And so this is the starting point, the treatment of residual waste. And then obviously we can produce energy in a very efficient way in the form of electricity and heat out of it. So yes, obviously it's inevitable that from the thermal treatment of waste, you generate some CO2 emission, but also we have to remember that, as I said also in my presentation, was the starting point, meaning that the waste-to-energy facilities already have benefits in a climate perspective for their three main contributions: landfill diversion, the replacement of fossil fuels in terms of equivalent production for electricity and heat, and then the material recovery from bottom ash. And especially in northern countries like in Finland, the second one, which is the energy substitution, is very important, because obviously for weather conditions, you need a lot of heat. Yeah. And the other thing that I see that is very crucial is that as far as the electricity sector, we'll see in the future a more penetration of renewable. The heat sector, it's much more difficult to decarbonize. Yeah. And that's where, through district heating, waste-to-energy could, already, but will still play a fundamental role in the next years.
Yeah, and that's actually to comment here. I think this is actually one of the issues that we're gonna talk more about today. I want to turn towards one thing that you touched upon a bit, carbon capture and utilization and storage. What about that? That's something that's oncoming.
Yes, I was just coming on that because, based on this, already on the benefits that the sector is delivering to the climate, then we can also think about negative emissions with the installation of CCUS technologies in waste-to-energy plants. Yeah. And this is something that is already happening in some plants in the Netherlands, at AVR in Twente, but also in Norway at the Klemetsrud waste-to-energy plant in Fortrum, that by 2024 will install a full-scale CCS system. Obviously, CCS and CCUS technologies are not bulletproof, meaning that they will not be the solution for everything, but they will be part of the solution. First of all, because CCS technologies are not fully mature on some aspects. And so you need also a proper technical and economical analysis before the installation. So also the sector will probably require time through the years before having full-scale application.
Yes.
But this is
We
something already happening.
I'm sorry to disrupt you, but we actually have a question from the audience. Sanna.
Yeah, so we have a couple of questions, but here Oras Tynkkynen asks about the CCS. So can you give a rough estimate of the carbon price required to make CCS from waste to energy plants commercially attractive?
Okay, that's a very good question, and it's very hard to give a direct reply on a cost. It's difficult in the sense that CCS technologies, as you might know, are not cheap technologies because the capturing of the CO2 obviously requires not just energy but also investments, and the cost is strictly related to the size because CCS technology they see a lot economies of scale. And so in this sense, as I said before, a proper technical economic feasibility should be assessed before the installation.
Yeah. Actually, I think we have a comment from Henry here.
Yes, thank you, Fabio. I think this Green Deal and going the right direction in Europe is vital. But we have to bear in mind one fact, that Europe is a huge continent. So this waste management practices vary a lot. So what we see as a best practice in the Nordics, for example, it's not the case in many other parts of the Europe. So this is a transformation process. So it has to happen in stages. And we totally see that these waste to value solutions play a vital role in this respect. So there are certain technologies that are implemented now in, for example, the Nordics. It has happened in stages. Fabio mentioned the CCUS, for example. So of course, we cannot go into kind of best practices immediately. As I mentioned, it's a process. It takes time. And one thing that we have to bear in mind also is that Europe is the benchmark, is the best of the best. So everyone is watching us. So we have to remind us that these technologies that we implement now, these are the future of decades to come in the developing countries. So we have to remember that companies who are actually providing these type of technologies will have a huge business opportunity outside of Europe. So whatever we do here will play a major role in the future in the developing countries.
Yes. I think the aspect of carbon handprint is really important. But then there's also another aspect, the economic aspect, which we already touched upon. Suvi, do you have any comment on this?
Yes, we have to remember, especially when we talk about energy and we are in the energy sector, that the discussion has been, when we talk about sustainability, the discussion usually focuses on environmental sustainability, and that is a good thing.
Yes.
And although technological development usually falls into that category, but then again there is two other aspects on sustainability also, and whether the one is economical and the other one is this kind of accessibility to energy. And if we talk about developing societies, and that is the main thing to actually to take into consideration, that okay, they have to be economically feasible, those solutions, but also to guarantee the access to the energy. There's huge, large regions in the globe that actually don't have an access to energy. And when you have access to energy, you have access to the development.
Exactly. There is one more question, I think. Sanna?
Yeah, I think we'll take one from Jukka Salmela here. I think it goes with the theme that you already talked about there a little, but why the development of waste to energy has been so slow within the EU?
Fabio, do you know the answer best, I think?
I think I do, and unfortunately, I think I do. Unfortunately, we see still a lot of public and social opposition towards waste-to-energy technologies, which somehow is regrettable because the real importance and the role of waste to energy has not been truly acknowledged so far. And this has slowed down a lot the development and installation of new plant. But as I also said and showed in my slide, there is still a need for capacity in the future for the treatment of residual and non-recyclable waste. And especially in some countries, especially in the southern European countries, that's more valid. And so, as I concluded in my slide, a lot of work still has to be done with the local communities in order to discuss with them the real benefits and real impact that waste to energy has. Because, as also we were saying before in the discussion, Europe is leading and will be leader in this way, and European benchmarks are the one that all the world is also taking as a reference. We recently have in the waste to energy sector the revision of the BREF for the best available technologies, and the sector already complies with the most stringent industrial emission limits. And so even in terms of health impacts, there are a lot of studies out there on a scientific and also technical level that proves what are the real aspects and the real impacts of waste to energy towards the health of environment that can be considered negligible.
Thank you, Fabio. There's one quick comment, and then we must move forward.
I would like to maybe add a comment that waste to energy is not mass burning. So waste to energy is a technology that kind of enables the circular economy to happen in full scale. So those waste fractions that are not economically feasible to recycle, those should go to waste to energy, right?
Exactly.
So as I mentioned, the transformation process, so this happens in stages. So in certain countries, they start with recycling and these pre-sorting units, and then they move into this CCS and CCU type of solution. Yeah. So it's good that in each country we have different paths to this.
I think this is a excellent opportunity to end this discussion here. We would love to continue, but we have to move forward. So thank you, Fabio. Thank you for the comments and thank you for the questions. And I think it's time to move towards our Finnish context. So in Finland, waste to energy has been the solution that has ended the landfilling of municipal waste. In the space of little more than 10 years, we've built a system and we've joined Western Europe and our Scandinavian friends in terms of waste utilization rates, and waste to energy has also been crucial. It's been an elemental part of reducing the use of fossil fuels, especially in local heating. Connected to some of the best district heating networks, I think Finnish networks are great. These solutions provide a clean, sustainable, local form of energy. But of course the work is not over yet, as we heard. And as Finnish Energy just recently announced, the Finnish heating sector is decarbonizing even more rapidly than we previously thought. So of course there are strict new targets to meet regarding recycling, as we heard, but also Finland is aiming to be carbon neutral quite soon. So to tell you about this path and how we're going to move forward with it and what kind of policies nationally are going to help us towards that goal, we have Karoliina Muukkonen from Finnish Energy. So Karo, please go ahead.
Yes, thank you. And thank you for the opportunity to speak to you today of the whole Finnish energy system and waste to energy in it and the related policies. So I work at Finnish Energy, and we represent all the companies working in the energy sector here in Finland. And next, I have a couple of slides of the energy production of the electricity here in Finland and the different ways of producing it, and then the district heating. And maybe the one thing we can take on of these slides is that the climate neutral production is actually pretty high already here in Finland. And that's maybe a good place to start. or maybe continue on this work we are doing here. But yeah, let's go deeper on how we are doing with the emissions on the energy sector and what we are expecting in the future. So this picture is from our roadmap, and this work was done in about 2 years ago. 2 years ago, and then we committed to halving the emissions of district heating and related electric production by the year 2030. And the reason I'm showing you this slide now is that the original work for the roadmap has actually already now gone bad or gotten old. We were surprised by ourselves, but the development in the past years has been so fast, and the transition is ongoing, and the decrease in the carbon dioxide emissions has been so fast that we had to update our roadmap. And this picture is from that. And here you can see that all the emissions are going down fast, and one main thing affecting to it is the ETS carbon price, which is here represented by the birds flying up to the sky. Here you can see a little more in detail the numbers for the emissions, and not going further into this, but you can see that in 2050 there ain't that many fuels bringing the emissions on the table. There actually is just others, including the wastes. On this slide, and we are going to stop here for a while. Here you can see the chart which shows the updated evaluation of the carbon dioxide emissions in district heating. And this is the change we had to make because the decrease in the emissions of the district heating is happening actually a lot faster than was expected. And when this transition is happening, bioenergy and waste to energy are actually playing a very crucial part of the production palette for the next decades. There are some, for example, utilization of waste and ambient heat, which are becoming more common, but they are not going to be the main production way in a while. Our experts have evaluated that the share of these waste and ambient heat production might be 30% in 2030. So it leaves a big share for bioenergy or waste to energy. But one thing I'd like to ask here or wonder here is what will be the role for the carbon capture in the future, especially when we are going post 2050 time, when we are not only reaching climate neutrality, but also negativity. Yes. So into the waste sector, when it's going to be one, as we saw a couple of slides ago, it was the one production that was left for emissions of carbon dioxide. So how to reach the goals on that sector? How is the development ongoing, and what kind of regulation is expected to waste to energy? Well, first look at how we are doing. And this is kind of fact that the emissions of waste to energy are decreasing when the goals for the recycling are achieved. And here you can see the both the emissions from waste combustion in year 2018, and then the evaluation of how they are coming down if the recycling of the household waste is met. So how are we doing? Here is a chart where you can see that the combustion has actually become the main treatment method for municipal waste, represented here on the chart on orange. And here on the left, you can see the target shares for Finland for recycling of the household waste. And the target for last year, for 2020, was 50%. But unfortunately, the fact is that these goals are a bit far away now. 2020, we recycled 42% of the household waste. So we are now already behind, and the target is getting stricter as we move forward, being 65% in 2035. So you can see we have a kind of a problem here. The emissions of the waste to energy are coming down if the recycling is coming up, but it's not happening. So what are we going to do? Well, our government hasn't been sleeping on this matter. They have been researching a lot of what kind of regulation should be added to the sector. And here on this slide, I've listed a few mechanisms for policy. Right now, actually, the waste law is being accepted and implemented, but of course, it remains to be seen what effects it will have. Both the strategies for circular economy and bioeconomy are both being renewed this year also, and there will be maybe some tools for this also. But last year, there was a study ordered by government, by the Ministry of the Environment, and done by AFRI, and they studied the effect waste incineration taxation would have not this time not on the economical side, but also on the emissions and the share of recycling. And also other waste policy measures were explored. To mention one that I find important tool is this government's Green Deal program that could be implemented instead or alongside the taxation. And moving the waste to energy sector from the effort sharing sector to ETS has been studied before, and it was not estimated here. Here is the link to the study. Unfortunately, it is in Finnish, but you can see you can have a brief abstract in English also. I'm not sure whether this study will be translated or not. This was published 3 months ago. Yeah, but let's go through the key findings of the recent study, which was waste tax does not pay off, but sector-wide Green Deal might be worth a try. The key result of the study was that waste incineration tax at the analyzed level does not result in significant recycling or emission impacts. And the voluntary agreements such as this Green Deal could be a better way to achieve it. The Green Deal would have to have some lines or restrictions to it. Of course, it had to be clear and ambitious, measurable, and all the actors would have to be committed to meeting the requirements. And one important key finding was also that when you are trying to regulate the waste sector, you have to regulate the whole line. You can't regulate from the other side and try to be effective that way. If the problems are in the beginning of the sector, you can't regulate it by regulating the end of the line. So a holistic approach is needed here. I would be happy to tell you that we are negotiating the Green Deal right now with the government, but unfortunately I cannot. We are kind of on a timeout right now. I've been told that all the different tools for regulation are still being considered, although it's recognized that taxation will not solve the problem. However, anything has to be decided, and it's greatly dependent also on the EU-wide policies you heard before. But Finnish Energy is hoping that we get on continuing the discussions of the Green Deal, actually at the end of the summer or in the autumn. Yeah, let's hope that will happen. Yes, this was all I have for you today, and looking forward for the discussions. Thanks.
Thank you so much, Karoliina. Actually, we could begin with a question from the audience. Sanna.
We have again a question from Oras Tynkkynen. So, recognizing how much more difficult it is to reduce emissions in the hard-to-abate sectors, including industrial processes and agriculture, shouldn't we aim at fully carbon-neutral energy by 2035?
Karoliina, what do you think of this proposal?
Yeah, thank you. Well, in an ideal world, maybe we should, but we just don't have all the technologies to use right now, and also when we have invested in some technology 5 years ago, it really wouldn't be beneficial to anybody to just stop using it right now, but to use it to the end and use it effectively and so on. But of course, there are a lot of cities in Finland that have set this goal for them.
Yeah, I think the 30s are approaching fast, as you said, and there is a certain sense of urgency also to find the solutions. But on the other hand, we have to recognize that many of these technologies are not ready if we don't develop them actively and invest in them. And I think this is important to understand. I think we might have some comments here from the panel as well.
I would challenge that a bit. I would say that the technologies are available. But what is the cost of utilizing these? You know, what makes economically sense?
Yeah.
So that the whole business model needs to be there. So I would say that there are ways to become carbon neutral even by 2030. But that requires a huge effort from the political decision makers, and the system has to also support this.
Yeah. All right. One thing you mentioned was, of course, the way the Finnish policies are developing, and one thing that I think might be quite interesting to our sector is, of course, the possibility of these national Green Deals. We heard about the European Green Deals, but what is this whole national Green Deal process, and what could it mean for the waste-to-energy sector?
Yeah. Well, the big picture is that our government is doing these Green Deals with different sectors to decarbonize or to get the emissions down in some ways, and we see that it could be actually a good tool also for the waste sector to get everybody to act and get some actions ongoing right now, which maybe wouldn't start otherwise. And the positive thing is also that the measures could be decided locally or regionally. Because we are a long country also, and it's a bit different depending on the area. And the one thing, good thing is also that when we compare to taxation, for example, taxation doesn't really push enough for the development, and in some cases it could be even so that it takes away the money from the new investments that are needed right now. And one thing that could be put forward in the Green Deal might be CCS.
I think this is certainly one of those issues that will affect the whole sector, and not just waste to energy, but also we have a very large bioenergy sector in Finland and forestry industry. So I think the possibilities of CCS in those sectors as well is something that need to be looked into. But as we saw, Finnish district heating is really decarbonizing and becoming climate friendly quite rapidly. Of course, there is still perhaps this kind of understanding or wrong image in the public sense that district heating dwells in the past, that it's an old system, perhaps a polluting system. And of course, we know that that's not the case anymore. But is there this kind of a risk that people are going to neglect the heating networks as a part of this transformation where we go towards the future?
Yes, I'm sorry to say that you are a little bit right on this matter. There has been some conversations of the image of the district heating, and I feel that it doesn't fully base on facts. Yeah. As you just seen, we have made a great progress on the getting the emissions of the district heating down in just 2 years now, and it's going to be continuing in the future. So it might be in the history that there has been a great share of fossil fuels everywhere used for district heating, but it isn't really so anymore, and the amount is coming down every year. And as a sector, we see the opportunities district heating has in the decarbonization and connecting all the different ambient and waste heat sources to the consumers. And I feel that it is also seen in outside of Finland and maybe in other countries, but the discussion here seems to be a little bit odd, I might say.
So we might consider ourselves a bit blind to the successes we've had. Suvi, actually, what do you think is the role of these heating networks, and what can they do?
So actually, if we think about hydrogen, for example, we are kind of living in a hydrogen hype at the moment in European Union, and seeing huge investments and for example, by Germany to the hydrogen economy and the coming investments. But one criteria to the feasible hydrogen production is actually the existence of a heat network, because producing a hydrogen production actually means that we are also producing heat. Exactly. And how we actually, if we want a hydrogen production to be feasible, then we have to fully use that heat also. And that is where the district heating network comes into play. And actually it supports the hydrogen economy and hydrogen technologies and that the development. And then if we think about how we can increase energy efficiency, and of course we have also the return lines in the district heating. Why don't we take the heat also from the return lines and improve the energy efficiency? And that is certainly one aspect. So if we think about district heating and district heating networks, they are actually providing this kind of needed flexibility in the future to the future energy systems. And this kind of image of dwelling in the past, it should be more like an image of a forerunner.
Exactly. Henry, I think you might have a comment on this as well.
Yes. I think we as Finns, we are pretty modest, or we are very modest. I think our district heating network is, if not the best in the world, it's one of the best. So I would say that this would be actually something that we should even export the best practices overseas. I see that the future is in this decentralized, kind of smaller, more decentralized district heating networks in Finland, as we know that there are a lot of discussion about the peat production going down. So I would say that waste act as a good flexible part of this mix in the future. And as it was slightly touched, there is quite a lot of available waste in the market. So most of the municipal solid waste goes to these big incineration plants, but there is a bundle of industrial waste, for example, available, which could be produced locally as district heating or the CHP, which is in Finland probably the most economical solution. So I see that this plays a key role in Finland, but we don't have to go very far, for example, to our eastern border, where is a huge market for this type of solutions.
And I think also something that's quite interesting and something that is happening in Finland as well, I think, Karo, is the fact that we are getting into lower temperature networks, which really enable the use of new kinds of heat sources as well. So I think that's also one of these issues that's really important. Unless we have any bigger comments from the audience, I think it's time to move forward. So thank you, Karoliina, and let's hope that these policies and the work continues as well as it can. All right. So following this discussion on the future of Finnish energy and the waste to energy in Finnish context and district heating, we are proud to represent a cutting-edge local district heating solution that embodies the very best in Finnish innovation, the largest thermal storage in use in Finland today. I want to thank our partners Vaasan Sähkö and EPV for their contribution to this webinar, and let's see what this heat storage is all about.
Tervetuloa tänne Vaskiluotoon. Ollaan tässä Vaasan lämpövaraston päällä, seisotaan, ja tuolla taustalla näkyy tähän lämpövarastoon liittyvä rakennus, joka on rakennettu siinä käyttöönoton yhteydessä. Tästä lämpöenergiavarastosta on hyvin monenlaisia hyötyjä energian tuotannolle. Tässä lämpövarastoinnissa Vaasassa erityisesti on kyse siitä, että tässä isossa lämpövarastossa voidaan kesäaikana esimerkiksi Westenergyltä varastoitua lämpöenergiaa sitten siirtää tuonne syksyn ja talviajan käyttöä varten. Sitten on vielä laajempia hyötyjä sähköjärjestelmää koskien. Esimerkiksi tässä lämmön ja sähkön yhteistuotannossa voidaan sitten keskittää tätä sähkön tuotantoa semmoisille ajoille, jolloin sähkömarkkina erityisesti kaipaa sähköä. Ja silloin tänä aikana tuotettu lämpö voidaan sitten tuolta varastosta myöhemmin hyödyntää. Tämä niin kuin yhdistää näitä lämpö- ja sähkösektoreita. Silloin puhutaan sektoriintegraatiosta, ja tässä elementissä tämä lämpövarasto onkin sitten tämmöinen liittävä tekijä sähkö- ja kaukolämpöjärjestelmien välillä. Lämmönvarastointi on tämmöinen nouseva trendi tällä hetkellä, ja se tulee varmasti hyödyttämään jatkossa yleisesti sillä tavalla, että kaukolämpöjärjestelmä tulee olemaan entistä puhtaampi ja auttaa meitä saavuttamaan tämän hiilineutraalisuustavoitteet. Eli tämmöisen lämpövaraston avulla voidaan sitten hyödyntää näitä uusiutuvia energialähteitä entistä tehokkaammin ja siten, että niiden kapasiteetti saadaan käytettyä maksimaalisella tavalla. Eli tulevaisuudessa tämä lämpövaraston avulla varmasti fossiilisista polttoaineista päästään eroon aika tehokkaasti ja voidaan hyödyntää sitten yhä enemmän näitä hukkalämpöjä, uusiutuvia energiaa ja kiertotalouden energialähteitä.
Well, that was really interesting. We've talked quite a lot about reaching these carbon targets and reducing our carbon footprint in Finland and Europe. But the climate waste and pollution crisis is a global issue, and we can do a lot at home, but it matters little unless the big picture changes. Finland is a technology leader, and our next speaker has ample experience in this kind of leadership, having traveled around the globe to complete challenging projects in very challenging environments. As CEO of Voima Corporation, Henri Kinnunen is doing his very best to ensure that Finnish carbon handprint really affects things globally and makes the world a better place. So thank you, Henri, and let's see what there's in store.
Hello, my name is Henri Kinnunen and I represent Voima Corporation. It's my honor and pleasure to be in this webinar hosting our company. So Voima Corporation was established in 2017. We wanted to create something totally different for this market. We created a totally own product, Waste Voima modular waste to energy power plant, aimed to reduce significantly the waste landfilling. We really want to boost the decentralized waste management, decentralized energy distribution. We want to cut down the waste logistics cost With our own product, we do our own technology. We can deliver these plants, and with our partner, we can also operate these plants. Global company trying to tackle the global waste problems as such. With whom we work? We work with waste management companies who have access to waste. We work with energy companies, industrial parks. In different markets, we work directly with project developers, with energy funds, renewable energy funds. The big difference to many others is that we can pretty much take most of the waste fractions that are available, mentioning the few: municipal solid waste, industrial waste, agricultural waste, even some part of the hazardous waste, medical waste, and also this plastic problem is a big global phenomenon. So all types of plastics from the oceans, rivers are very much welcome. And the business model is the following. So our customers typically collect the waste, they have access to waste, or they collect the tipping fees. Then comes our plant. Our customer needs to only decide how he uses the steam. So we either produce directly electricity, district heating, or then it's a combination of those. So very, very flexible system that we are providing. And the world is moving really much towards the green future. So this carbon credit schemes are also available for the customers, and we try to maximize the value of the waste. So up to 96% can be valorized. So also this bottom ash can be sold or then given format. A few words about the concept as such. I don't go into details too much, but this modularity, this enables integrating new solutions and technologies easily and cost efficiently, also in the future. So this is totally a prefabricated concept. So it's very fast to deliver. It can be scaled, can be moved. It doesn't take too much space. And then in the future also it can be upgraded. So easy to build, easy to maintain, and even in the future can be upgraded with different solutions. So we know that our customers need to think for the future as well. So when you're making the business decision for next 25 years, waste Voima solution is the solution that's going to be there all the way. So in this short video, you see the Voima line process. So the fuel is fed to the grate first, the grate combustion system, then the flue gas flow, and we do meet all the regulation what comes to emissions. So we have a state-of-the-art flue gas treatment system. We collect also the bottom ash, the boiler ash, and the APC ash is also taken away from the feed separately. Then we have the own boiler. We manufacture that as well. Then we create steam, and we feed that to the turbine. In case it's a district heating plant, then it of course will be directly to the system. But in practice, that's how simple it is. So Voima is very, very flexible when it comes to the delivery. So we can take the full EPC delivery through our partner Sumitomo Heavy Industry, Foster Wheeler. Can also deliver the technology as EPC, kind of the turnkey solution. And we have also developed systems for the ecosystem and the pre-treatment facility, which I show a bit more in detail later. About the process, the grate combustion process, which is the bankable technology in Europe and also overseas. So we know that this is the working solution for long term. Showing what is radically different with our concept. So you can expand the plant. So we pretty much can deliver a plant to any size of a landfill or a waste management company, starting from one Voima line, expanding to 2, expanding to 3, or even deliver the full 4-line solution. So this would be already the size of Westenergy plant, 200,000 tons per year municipal solid waste. So it's very flexible, also movable system. And it can be integrated with the pre-sorting unit. In certain markets, this is really much welcome. So this is something we offer as well. This is wastewater installation video. As you see, all modules are prefabricated. So the installation time at the site is decreased to a maximum. And each module can be delivered by truck, so 20 to 40 feet containerized modules. We have tried to make it as fast as convenient as possible for the customer. So turnkey solution from us within 15 months from signing the contract, which is pretty okay in this market. So all modules have been already designed, so we know exactly in which sequence we are building this, and multiple lines can be also delivered at the same time and built. There are different options to modify this in case of a need, so we can also build different shapes. It doesn't have to be this I shape. It can be also based on the site conditions. So as long as the customer can give us the coordinates of the site, we can easily modify also that it comes to a need. So it can be also next to an existing power plant. It can be next to an existing waste to energy plant. It can be an extension. So one Voima line doesn't take too much space. We are talking 4,500 square meters per line, which is not much. So this is something that we have developed lately. Then a few words about the Voima ecosystem. We strongly believe that this is the future of circular economy. So by multiplying different technologies into one and maximizing the value of the waste, so up to 96% of the waste can be valorized, and I think this will go to 100 in the future. So our standard Voima ecosystem solution can integrate the pre-sorting unit. We remove the organic material, either we do biogas or composting. And then the remaining fracture, which cannot be recycled, will come to Voima line, a waste Voima plant. But this is something that can be easily upgraded to any level. So we see fascinating business opportunities with these carbon capture technologies. This is something that will happen in Europe, most likely within a few years already. This APCR ash can be also treated economically. We are seeking solutions for that. This biogas production, we can utilize the landfill gas. With the production, we can do landfill mining that will bring additional benefits to this system. This HTC, hydrothermal carbonization, is something that we believe strongly that this is a good solution for the bio-based, sludge-based waste in the future. This can be also added as a potable water treatment to create even drinkable water, but also water for the plants, for example, creating fertilizer production. So this depends totally of the market. So I would say that this is the future of a circular economy, definitely. And Voima has already technology available for that. We are integrating different technologies. This can be also easily integrated with batteries, for example. So I would say the sky is the limit for the ecosystem. So if you are interested in to learn more, please go and visit our website, voimacorporation.com. We have nearly 3,000 followers in LinkedIn, so you are more than happy to start following us there. We post something nice every week regarding circular economy. So I thank you very much. This was an interesting webinar. I hope you enjoyed it as well.
Thank you, Henry. So interesting, such a fascinating ecosystem and modular concept. I think we can begin with a comment from the audience. Sanna, please.
Yes, so we have from Reimar JC von Wachholz. He has just a comment that the enormous experience with district heating systems in Finland is really a good asset to develop smaller decentralized carbon minimizing district heating solutions. not only in the eastern neighboring countries, but for sure in the other parts of the EU?
Well, this is definitely the case.
Yeah.
I mentioned the eastern border, so Russia has 40,000 landfills. So we see that there is a huge opportunity for us there, not only for us, but different players as well. So this CHP, which is probably not so much recognized in Europe as such, but in Finland that's the mainstream.
Yeah.
So many of these Eastern European countries, for example, have a district heating network available. So waste to energy combined with the CHP function, I see big opportunities there, definitely. So thanks for the comment.
That's good to hear. I think we've also established that this kind of a one-size-fits-all approach isn't going to work in waste management when we look at these different cases globally. So how is the global market in waste to energy looking to you, and what kind of services and what do you think is your place there in that market?
Well, we are very modest. We only want to take 5% from the whole market. That means several billion euros. So,
Ostrobotnian modestness.
Just kidding. But it's a huge market. The waste amounts are growing in these emerging markets 5 to 8% per year. And these waste to energy solutions are not recognized yet.
Yeah.
The waste management practices are increasing and developing. It's a huge market. There is room for everyone. What we see is that, okay, there will be place for big plants as well, but the size of the plants will definitely decrease, not only in Europe, but that will happen also overseas. For example, these island states, which don't produce that much waste. So we have developed a product and solution that is economically feasible for a smaller size. And this has not been the case in the market by far. So, and we see that having a flexible system to be able to treat different types of waste during the lifespan of the product, that we know that the waste will change. That you don't even know how the waste in your plant will be in the future. So,
but we have some ideas what it's going to look
you
like.
You need to have a robust solution that is there during the way when the customer can make the investment.
Exactly.
Decision. And what I see, I speak very strongly about the ecosystem. So in the developing countries where the waste is moist, you really need to have a certain solution. We haven't invented yet a solution to burn water. So definitely there is room for this type of ecosystem, and the sky is the limit for those. We can integrate the CCS, CCU, different technologies into one solution, but we have to start somewhere. And waste to energy is the kind of cornerstone of this whole system.
Yeah, I think looking at the life cycle and lifespan of these, and as you mentioned, the changes when you bring this kind of modern waste management system to somewhere where there wasn't one before, of course you're going to see a lot of change, and I think adaptability is the key to make a successful product. Suvi, you have a comment.
Yeah, actually a comment basically for Henry, because this is a really good example, this kind of modular and scalable solution that is actually already designed and planned so that it meets the needs of a certain, and also the constraints of a certain target markets, and it's very impressive. It's nice to see something like this coming from Vaasa.
There's another question from the audience, so Sanna.
So we had an earlier question from Julie Kring, and she asks, what opportunities are there for systems that convert agricultural waste to stored carbon?
Does Voima have an answer to this?
There are several technologies available. Of course, first that comes to my mind is the biogas. Biogas. Another one is this hydrothermal carbonization technology that we also have investigated a bit, where it's kind of sludge-based biomass that can be converted to hydrochar. And definitely this biogas is already an option in Europe, so definitely in the developing markets as well. That will not kill the MSW problem yet, so that can be combined. I think that's the key message in this ecosystem, that you can combine different technologies, different waste into one stream. It doesn't have to be municipal solid waste. You can bring industrial waste, you can bring agricultural waste, and still make a profitable project out of that.
Exactly. Something we noticed looking at your presence on the web was your series Drowning in Waste. So you've traveled to many different places in the world. We have very short time here, but can you tell us some kind of anecdote story from the world of your experiences?
Well, I have been fortunate guy. I've been traveling quite a lot and visited more than 100 landfills in several countries. So what I can say that what we do here in the Nordics is really the best in class. So there is definitely room for improvement. So the waste management practices vary quite significantly in the developing market. Yeah. But definitely there is room for improvement. What I see every time when I'm traveling this new location is that the willingness to do good, and when we promote our products from Europe, we see that there is definitely a fit. So now we need to find a way to make it economically feasible for these countries to buy this solution.
Yeah, yeah.
So that is another topic, maybe another webinar that we can discuss.
Certainly, certainly. I think if we look at the question of business models, how to find the right way to work, I mean, that's a universal question. Whichever technology you're going to use, whichever kind of technologies you're going to utilize, you have to find the right ways to make it profitable and sustainable at the same time.
But one important fact is that when you have a decentralized system, so then you don't need to transport the waste for long distances. Exactly. That is really much what we are promoting. So for example, in Russia, you don't need to transport 1,000 kilometers of waste. That doesn't make any sense. Yeah. So the carbon footprint actually comes smaller. You have a decentralized system to either produce heat or electricity. So that's in a nutshell what we promote.
Thank you so much. I think it's now time to turn to us at Westenergy. As a mainstay of the local energy ecosystem in the Vaasa region, as well as a key component of waste management in whole of Western Finland. For the last decade, we've been facilitating decarbonization, sector coupling, and circular economy. And now I would like to tell you what the next steps could be like and what kind of policies and efforts we need to get there. So it's me on the stage. Let's see what happens. So, thank you. My name is Juhari Batti, and I'm going to talk about the path of decarbonization that Westenergy is going to take in the next decade. First, let's delve a bit into Westenergy. We are a circular economy company which operates a high waste-to-energy facility in Mustasaari, close to the city of Vaasa. Annually, we refine up to 200,000 tons of source-separated municipal waste into energy materials. And we do this with extremely high efficiency, extracting even the energy of the water vapor that remains after our process. We also return over 30,000 tons of recycled materials ranging from valuable metals such as gold to construction minerals back to use. So let's talk a bit about our efforts of decarbonization, what we have done so far. So as you see on this slide, decarbonization has been a cornerstone of our strategy since the very inception of Westenergy in 2007. We have methodically worked to reduce the environmental impact of waste management and to make district heating climate friendly. Our production has replaced conventional fossil fuels. We've halved the CO2 emissions of district heating thanks to the high biogenic content in the waste we process. With the help of our local energy partners, excess heat can now be stored in state-of-the-art thermal storage to provide demand response and added heating for the winter months. So this further increases the efficiency of district heating. We've also helped to end the landfilling of municipal waste, significantly reducing pollution and especially methane emissions, which can be up to 20 times as potent as carbon dioxide. And we are searching for the best technologies to minimize the impact of our transport, for example, with the help of locally produced biogas. We've improved our process, modifying our boiler, flue gas screening, and other systems to reduce emissions and increase energy efficiency. The flue gas condenser and scrubber alone increased heat production by almost 1/4 without any need for more fuel. To summarize, we have continuously reduced the specific emissions and fuel consumption of our process while providing more and more energy. So let's turn to the challenges ahead. As we can see, there is a growing urgency for effective climate action. The regulatory landscape is changing rapidly in Europe, as we heard, and the EU is taking a much more active role in curbing greenhouse gas emissions already within this decade. The European Green Deal is set to transform more or less everything when it comes to the environment, energy, recycling, and so on. there's growing concern whether combustion processes can be a part of this transformation. At the same time, the price of fossil emissions in the EU ETS scheme continues to skyrocket, just recently hitting the previously elusive figure of 50 euros per ton. 100 euros at the end of the decade no longer seems far-fetched. Furthermore, the International Energy Agency has declared that the rapid pace of decarbonization that is sought after can only be accomplished with the help of carbon capture. For Westenergy, this is a significant turning point. We've already done a lot of work, but our present methods to decrease emissions and increase energy efficiency are reaching their maximum. We will need new ways to reach targets such as recycling rates close to 70%, and as the Finnish Energy low carbon roadmap envisions, green energy is intrinsically linked with successful circular economy. The most important thing is that this transformation cannot merely be accomplished from the end of the value chains. The only effective way is to begin efforts at the start of value chains where design and material choices are made. Future products and packaging must reduce waste and increase recyclability by design, and there must be market demand for recycled materials too. And all of this requires robust policies. One good example, one step in the right direction is of course the EU Eco-Design Directive. Waste management must become more intelligent, and potential raw materials must be separated from residual waste even better. And all of this of course helps to reduce emissions. But of course there will remain a significant amount of hard to recycle materials, residues from recycling processes and so on. And we must continue to harness their energy and materials emission free. And carbon capture is, we think, the answer to this problem. So let's go into what carbon capture, carbon negativity means. Our strategic path to curb our remaining carbon dioxide emissions began in 2019. Thanks to a grant by the Finnish Ministry of Economic Affairs, we were able to begin a project to find the most suitable solutions. Before the pandemic hit, we had time to visit some of our more advanced colleagues in Scandinavia. The CCUS pilot plant in Oslo, pictured on the left, which is now being turned into a full-scale waste-to-energy capture facility, opened our eyes to the rapid pace of development in Europe. The concept of CCUS is simple enough. In our specific case, with the help of optimized post-combustion capture with high efficiency and relatively low energy demand, over 90% of the carbon dioxide in our flue gas can be captured and either pressurized or liquefied to suit the need of the rest of the value chain. We can also harness back the energy that was used to capture the carbon as heat. I must emphasize the word value here, because at the end of the day, this is about bringing value back to society, value in terms of reduced and even negative emissions when you take out the biogenic carbon, and also value in terms of enabling new products created from this carbon feedstock. Whether the CO2 is shipped for storage or used in products, we will need partners to make our process completely climate positive. CCUS is an ecosystem effort with room for technology providers, transporters, and end users alike. The cost of capture has already decreased significantly thanks to improvements in the technology and energy efficiency of these solutions. As a key part of the local district heating system, we will need to also ensure that our capacity stays high and our pricing competitive. So we need that efficiency. And perhaps most importantly, the opportunity cost of not capturing CO2 may rise rapidly if as we know, the EU ETS is being extended to all kinds of new sectors as also heating. So the pieces of the puzzle are perhaps starting to find their place. But what then? Let's go to the next slide and talk a little bit about the conditions under which this happens. So we have been here before, haven't we? Technology is first hyped and then the reality is set in. So in the early 2000s, carbon capture was set to become a flourishing industry, but the climate demand wasn't urgent enough. It was still half-hearted, and the optimization required for these systems to be efficient wasn't yet there. So as we know from many technologies, it can be hard to find progress after this initial bubble bursts. But as we see, we, for example, now have market-based wind power in Finland. So not something that was perhaps evident 10 to 15 years ago. The right technological steps, the right ideas, cooperation for successful business models, and the right regulatory environment can pave the way to success. Most Nordic countries have strict targets for carbon neutrality and plan to use carbon capture as a significant component in their strategy. Sweden aims for the mid-2040s, Norway 2030, even Denmark, which only aims for the 50s, has national CCUS plans already underway. And it's not just the Nordics. For example, just last week, the Dutch government granted 2.4 billion euros to the CCS project of the Port of Rotterdam. All of these countries have understood the necessity of negative emissions in their plans and are pushing for results with national measures. What we can learn from this is that while carbon capture isn't a silver bullet and can't replace other climate actions, it is crucial in complementing them. In Finland, we have the technological expertise, many kinds of new projects going on that can catapult us into the forefront of this transformation if the right policies are put in place here as well. Looking at the role of biomass in our energy system and our national target of carbon neutrality by 2035, one can ask whether we can afford not to do this. So, what about Westenergy's plans? What is our vision of the climate positive path? We have been looking into the most suitable solutions for a few years now, and we're in the process of gathering the right partners, right approach to go forward to the next stage. So we want to test these technologies at our waste to energy plant, perhaps going even into a more permanent intermediate scale solution before we step up to full scale. A crucial part of how fast we can move forward is, of course, the way the policy environment develops. To plan for a full-scale facility that will cost significant amounts of money, we need clarity in how our sector and our emissions will be regulated in the coming decade. This, we hope, also means policies that create demand for carbon capture. Alongside incentives, of course, further investments in the research and development will be needed. We will have to find the right partners to build this technology and partners to transport, utilize, or store the captured carbon dioxide. The likeliest way forward is with cluster-style development. We think that these pioneering ecosystems could also bring export success for Finnish companies. The recent news of, for example, Westwelding from nearby Teuvo joining the Norwegian Longship CCUS project as supplier is quite promising. We see three key benefits from CCUS that are going to help all of society. Firstly, the advanced technologies available today will make it possible to decarbonize sectors that can't easily be electrified, such as cement, refineries, and waste to energy. The cost of capture itself is already quite favorable compared to the carbon prices seen today, and benefits of scale in transport and utilization will also keep getting better. Secondly, the recycling of molecular carbon will enable the replacement of fossil feedstock in chemical processes, and carbon capture is going to be a key step in enabling large-scale hydrogen production. Finally, both the direct emission reductions and the additional carbon sinks created by negative emissions when you remove biogenic carbon from circulation are crucial if we want to succeed and go beyond the present climate targets. From all of these components, we think that a successful business model that creates value to society as well as our owners can be built. As you can see from the graph, in the 30s, we want to produce energy with negative specific emissions, energy which binds carbon away from the atmosphere and from increasing climate change. In the field of circular economy, there's a lot of talk about closing loops. So we aim to fully close the loop in our value chain so that energy, materials, water, and carbon circulate sustainably. Thank you. All right. There's a bright, if challenging future ahead for ourselves to get to that point, but I think we can do that. I have to ask, if we begin this discussion, I have to ask whether Voima has thought about carbon capture. I imagine this necessarily isn't the kind of technology to be used in developing countries quite yet, but how do you see this kind of market and what kind of offering could you have?
Yeah, we are a company that is looking for the future, and we definitely see that this will happen in Europe. This will definitely not happen in emerging markets anytime soon. But what I see that it has to be also an economical solution that happens. So yes, we are checking some solutions together with some partners. It has to be a modular system that can be easily expanded and meet the targets. But what I see that is a little bit a question mark still, that who is the off-taker for the if we have a carbon capture technologies available, that there has to be a business model. So what I would like to ask from Fabio, that do you see that this type of off-takers do exist in this time frame that we are given? For example, in Finland, you mentioned 2035, we need to be carbon neutral in this respect. That can we develop that system, that business model before that? So that is kind of my slight worry. I think technology is there. We do find that solution, yes.
We have Fabio still on the line. I think, Fabio, can you...
Yes, I'm here. I'm here listening to this very interesting discussion. Well, actually, you touched a very crucial point, I would say, because as you just said, carbon capturing technologies are there. And so let's say the power sector has been developing these technologies. And as you showed, it's not something new. So we somehow know quite well how to capture CO2, but then obviously there's an issue to where to store it and how to use it. And this is a key element, a crucial element in the puzzle, because first of all, a CO2 transport network has to be developed. And there are already some ongoing projects that also you have mentioned, the Northern Lights in the Scandinavian countries and also in Portos. But also in my slides, I left some references on other new transportation of CO2 projects ongoing in Europe. So not just in, let's say, the Nordic country. And then obviously there's the possibility of using it, but you need to find also market opportunities for the usage of CO2. Something, for example, that it's feasible, that it's done in the Netherlands, is the usage in the horticulture industry, so for greenhouses. And there's also the possibility to reconvert CO2 into valuable materials like minerals. And there are ongoing projects in the waste to energy sector of combining CO2 with bottom ashes for stabilization. And last but not least, somebody mentioned hydrogen before. Combining CO2 with hydrogen, there's the possibility to produce methanol. So that could be then further utilized in the chemical industry or as a fuel again. So there are possibilities out there, but as you correctly said, a business case has to be for sure evaluated. Exactly. So CO2 will have utilization purposes in the future, but considering also the amounts that will be delivered through possible CCUS technologies, also the storing into permanent geological underground spaces also will be important. So storage, but also utilization, both of them.
I think we need to, we might have some questions from the audience, but I think we are almost running out of time, so we have to move forward. So as you know, the clock is nearing lunchtime, and I think there's time for just one more thing. So circular economy has been part of the Westenergy business model since the very beginning. And we don't just want to recover the energy, but also we want to ensure that as much of and as many of the materials continue to circulate in a sustainable manner. Thanks to our long partnership with Suomen Erityisjäte, we've been able to accomplish this goal quite well. So here's CEO Jukka Manskinen of Suomen Erityisjäte to tell you how our bottom ash is recycled and how we can see some practical circular economy in action.
Suomen erityisjäte käsittelee Westenergyn pohjakuonia vuosittain noin 31 000 tonnia. Ja hyötykäyttöaste sille materiaalille on noin 99,5%. Se tarkoittaa sitä, että 100 kilosta vain puoli kiloa on materiaali, jota ei voida hyötykäyttää. Meidän laitteisto, joka tuossa takana näkyy, niin me erotellaan sillä metallit. Me saadaan siitä erittäin hyvin rautatalteen, alumiinia ja kuparia. Ja lisäksi saadaan mineraaleja. Meillä tulee 4 erilaista kokoa mineraaleja, joka on sellaista hiekan ja soran tapaista materiaalia. Sitä voidaan käyttää erilaisissa kerroksissa, kun tehdään niin kuin esimerkiksi kenttiä, tehdään väyliä, pyöräteitä. Eli tätä kautta, kun näitä voidaan hyödyntää maan rakentamisessa esimerkiksi, niin sitä kautta voidaan säästää ympäristöä, eli luonnon soraa, eli neitsellistä materiaalia.
It's been truly fascinating to hear how the waste-to-energy industry is set to develop in the coming decades and how we can help in fostering circular economy and fighting climate change. We've come far, as we've seen, but of course a long path still remains to be traveled. I'm confident with the kind of people that we have here today, we are able to make that path and reach those targets. So I want to thank you, all of you, of our speakers and our studio guests here today, and as well as our studio host, Sanna, so thank you, Sanna, as well. And of course, my thanks go out to Energy Vaasa for letting us have this opportunity. As we know, this spring has mostly been spent behind monitors in home offices, but I hope to see many of you next year at Energy Week, which will be held in March next year. And of course, there were a lot of discussions, as we heard, in the comment section as well, and please continue them. You can bring them over to LinkedIn and we can continue these discussions. I think it's very fruitful. I want to end on a note from Jukka Salmela, who I think crystallized the ideas that we talked about today. And what he said in his comment was that let's recycle value instead of tons. And I think that's a great line to end this webinar in. So thank you all for today and see you soon again.